Everybody. So now that we've finished going through the law of sines, we're now going to move on to the law of cosines, which is another way that we can solve oblique triangles. So just like our law of sines had two cases that we could solve using that law, we had case one, which was two angles and one side, and we had case two that was two sides and an opposite angle. Our law of cosines has two different cases that it can solve as well. So the two different cases that law of cosines can solve are if we have two sides and an included angle. And by included angle, I just mean the angle that sits between those two sides. So for example, it could look something like this: side, angle, side. Okay, so that would be two sides and the included angle that sits between those two sides. All right, and then case four is when we know all three sides. So side, side, side. Okay. All right, so either of these two situations are going to be solved using the law of cosines. Okay. All right, now here is the law of cosines. So law of cosines has three different equations that we'll use depending on which pieces of information were given in the problem. So these you guys do not have to memorize, right? These will be given to you on a formula sheet provided on the test. You just have to know how to use them. And just like when we talked about our law of sines, with any of these triangles, we're using capital letters A, B, and C to represent our angles, and then lowercase letters A, B, and C across from those angles to represent our sides. Okay. All right. So let's go ahead and take a look at example one and see if we can't use our law of sines in order to solve this. Okay. All right, so I'm going to start by filling in my information on my triangle here. So we have, first of all, angle A is 46.5 degrees. All right. Now I know that that means across from that would be my side A. And I also have side B has a length of 10.5. So across from that would be my angle B. All right, and then side C has a length of 18. So across from that would be my angle C. Okay. All right. When I'm placing my A, B's, and C's in here, it's completely arbitrary. It does not matter where you put your letters as long as A's across from A, B's across from B, C's across from C. Doesn't matter where your A, B, and C goes. Okay. Okay. So looking at this, I can see that we have two sides and the included angle. So this is our side angle side case. Okay. All right. So now let's go ahead and let's try and use our law of cosines in order to solve this problem. All right. Well, if we think about the information that we have here and we try and find one of our formulas, there's only going to be one of these equations that actually works right now because we don't have enough information to use all of them. So notice that for every equation, they all have all three sides, A, B, and C, but each one of them has just one angle in it. So with our information, we only have our angle A, so we're going to have to use this bottom equation. We have our sides B and C that we can plug in. We have our angle A that we can plug in. So we're going to be solving for side A to start with. So let's go ahead and plug in this information. We are going to have A squared is equal to 10.5 squared plus 18 squared minus 2 times 10.5 times 18 times the cosine of 46.5 degrees. Okay. All right, now because our variable is already by itself over here on the left-hand side, we can just go ahead and plug this into our calculator exactly like that. Let me pull up my little calculator here. Oops. Let me get them side by side. Okay. All right, so we have 10.5 squared plus 18 squared minus 2 times 10.5 times 18 times the cosine of 46.5. Let me double check real quick that I am in degree mode, which I was not. I was in radian mode. Okay, so now I'm in degree mode. And just enter, and that gives me my answer. So a squared is equal to 174.0519703878. Okay. All right, and then we just need to take the square root of both sides to isolate a. So if I do the square root of the answer, I come out with 13.1928757437 as my a value. Okay, so that's our first answer. Now, let's keep going with it. Okay. All right, so the next thing we want to do is try and start solving for these angles on here. And now that we have our third side, we can use any of our formulas. So say, for example, we look at this top formula. We have all three sides, A, B, and C. The only thing we're missing is angle C. So if we plugged everything in, we'd be able to solve for that angle C. Similarly, if we used the middle equation, we could plug in all of our sides and we'd be able to solve for angle B. Okay, either one's fine. It doesn't matter which way you go. I'll go ahead and just solve for angle C because it's the top equation. Just kind of making a choice here. Okay. All right, so I'm going to start plugging everything into that top equation. So I have C squared, that's my 18 squared, is equal to my A squared, which we just found that, plus B squared, which that was 10.5, minus 2 times the same A value again, times B, which was our 10.5, times the cosine of angle C. Okay. All right, now this one, our variable that we're solving for isn't isolated yet. So we're going to have to do a little bit more work in order to solve this one, but it's still not going to be too bad. Okay. All right, so first thing I'm going to do is I'm going to go ahead and just plug my 18 squared in. So I get a number for that. So that's 324. And then I'm going to go ahead and plug all of this in, okay? So don't plug everything in on the right-hand side here all together because these pieces, the 2 times the A times the B, those are attached to the cosine of C, whereas the A squared plus the B squared, those are not, okay? So we have to do these two pieces separately. So I am going to just going to scroll up and get that guy. So I've got my 13.19 squared plus 10.5 squared. So that gives me 284.3019703878. All right, and then I'm going to plug this chunk in. So 2 times, again, that 13.19 number times 10.5. That gives me 277.050390669 cosine of angle C. All right. Now, if we're still trying to solve for angle C here, we want to try to isolate this cosine. Again, remember these two pieces, they're attached. The 277 is attached to that cosine of c by multiplication. So if we're trying to solve for our c, next thing we want to do is subtract the 284 from the 324. So 324 minus that 284 number. And that gives us 39.698.0296122. Okay, and that's still equal to negative 277 cosine of angle C. All right, and then continuing to isolate this cosine function. So since these guys are multiplied, we want to then divide by, let me actually do it this way. Divide by, we need to do negative 277. All right, so that gives us negative 0.14328812 is equal to the cosine of angle C. Okay. All right, so then lastly, to get that angle C by itself, in order to get rid of or to undo the cosine function, we just need to use its inverse. So angle C is equal to the inverse cosine of that negative 0.14 number that we just found. So if we do second cosine of that number, we get angle C is equal to 98.23816055516 degrees. Okay. And if your decimals are a teeny bit off from mine, don't stress about that. That's just a difference in calculator models sometimes. So if you get maybe the last decimal is a little different, or you get more decimal places or less decimal places, as long as you're accurate up to about the tenths or the hundredths place, you're going to be fine. Okay. Now, obviously, you don't want to round along the way because that's just going to make your answers less accurate than they could be, but don't stress too much if yours aren't exactly the same as what I'm getting. Okay, so we're almost done. That was our angle C. All right. So the last thing we need to find is just our angle B, but that's easy at this point because now we already have two of the angles in our triangle. We know that there's 180 degrees to work with. So if we just subtract the two angles we have from 180, we'll have our last angle. So I'm just going to do 180 minus the 46.5 that we started with, minus the 98.2 that we just got, and we get our last angle here. So our angle B is equal to 35.2618394484 degrees. All right, so that is our final answer. All right, so this is the basic idea behind this law of cosines, okay? Really, it's mostly just plug and chug into the formulas, do a little bit of algebra, plug some stuff into your calculators. But as long as you're careful with your steps and you make sure that you don't, like drop a negative or anything like that, I don't think you guys should have too much trouble with it. Let's go ahead and look at one more example though. I'm going to go ahead and jump down to example 3 just to show you something with the side, side, side case. Okay, so on this one, I'm going to go ahead as usual and just fill in my pieces here. So I have side A is a length of 5. So opposite that is my angle A. Side B has a length of 8. Opposite that is my angle B. And then side C has a length of 12, and opposite that is my angle C. Okay, so this is, of course, our side, side, side case because we have all three sides of the triangle. Okay, so if we think about our law of cosines on this one, since we have all three sides and we're looking for all three angles, we could use any of the three formulas to start with. It's just a matter of which angle we want to find first. So if we want to find our angle C, use the top equation. Want to find your angle B, use the middle equation. And it really doesn't matter, just sort of pick one, plug it in, and go from there. Okay, so I'll go ahead and just start with angle C because it's at the top here. So I'm going to plug all my information into that first law of cosines. All right, so we are going to have C squared, 12 squared, is equal to 5 squared plus 8 squared minus 2 times 5 times 8 times the cosine of angle C. Okay. All right, so then we're solving for our angle C again, which means we want to isolate, first of all, our cosine of angle C. Let's go ahead and just evaluate some of this stuff here. So first, on the left-hand side, 12 squared is just 144. Okay. Then we have here 5 squared plus 8 squared. So 5 squared plus 8 squared is going to be 89. And then this chunk, 2 times 5 times 8 will just be 80. And still times the cosine of angle C. Okay. All right. Excuse me. Okay, so now we're just going to keep isolating our angle C. So we need to subtract the 89 over. So 144 minus 89 is going to give us 55. And then divide both sides by the negative 80. So I would come out with cosine of angle C is equal to negative 0.6875. And then lastly, to get rid of that cosine, just take an inverse cosine of both sides of our equation. So inverse cosine of that number. And we come out with our angle C is going to be 133.432536 degrees. Okay. All right, so that's our first angle. Okay, now we just keep going with it. Now, one thing I want to mention here, guys, is you might be tempted once you start a problem with the law of cosines to at some point switch over to the law of sines, okay? That is not a good idea, though. Sometimes it'll work out. Oftentimes you will get the wrong answer. So you can't just go back and forth switching between law of sines and law of cosines because it will not always give you the correct answer. So my best advice I can give you is if you start a problem with law of sines, finish the problem with law of sines. If you start a problem with law of cosines, finish the problem with law of cosines. Don't try and switch back and forth between the two laws because it can oftentimes cause problems that will result in the wrong answers, okay? So I just say this because I know that law of sines is a little bit easier and a little bit quicker to use. So I see a lot of people, once they get that first piece with the law of cosines, say, oh, hey, I'll switch over, but don't do it, okay? It's going to cause some problems if you do. All right, so once we have our first angle, we can just keep going with our law of cosines some more in order to find our next angle. So we have enough information to find either one of the angles that we want. I'll go ahead and just keep making my way down the row here, or down the column. So I'll use the second one in order to find my angle B. I'll put it right next to it. Okay, so if we're plugging into that second equation, we're going to have 8 squared is equal to 5 squared plus 12 squared minus 2 times 5 times 12 times the cosine of angle B. All right, so then start evaluating. So 8 squared is 64. Then we want to add the 5 squared and the 12 squared. That's going to give us 169. And then we want to multiply 2 times 5 times 12, which would give us 120 times the cosine of angle B. All right, isolating our cosine of angle B. Next, we'll subtract the 169 over. So 64 minus 169 gives us negative 105. And then divide both sides by negative 120. And we get cosine of angle B is equal to 0.875. All right, so then to get rid of our cosine, or to undo it, we just need to use the inverse cosine. So angle B would be equal to the inverse cosine of 0.875. And just plug that in your calculator. And we get angle B is equal to 28.9550243 degrees. All right, so once you have your first two angles, you can just subtract them from 180 to find your third. So our angle A, we're just going to take 180 minus the 133 minus the 28.96, and that'll give us our final answer here. So 180 minus 133.4325366 minus the 28.9550243, and we come out with angle A is equal to 17.6124393 degrees. All right, so those are our answers. All right, guys, so that's pretty much it for the law of cosines. I'll post a few more worked out examples in Blackboard. I'll post the rest of this handout worked out, but that is it for our videos. So keep working through these examples, check them with the notes that are posted on Blackboard, and then move on to your homework.